So we are today talking about key features of a parabola, and we're going to start with the part that's complicated for most students, and that's how do we identify the x-intercepts of a quadratic function when they're not precise. I can see there are two x-intercepts, but the place in which it crosses the x-axis I would have to estimate or guess on. So we're going to go back to using the quadratic formula as a way to get those precise points. This is the formula we're provided for question number 3, identifying the a is -1, the b is +4, and the c is 6. And now I'm simply going to plug them in. Remember, this means take the opposite sign of b. X equals -4, and then this is going to be 4 squared minus 4 times a times c, all over the entire thing, not just the radical. The entire thing is over 2 times a. Now I'm going to use a calculator to only take care of the business that's underneath the radical. So I grab my calculator and I do 4 squared minus 4 times a times c, and I get an answer of 40. Can you raise your hand if you also achieved an answer of 40 before you broke it down? Okay? So now I have x equals -4 plus or minus the square root of 40 all over -2. Now I'm going to grab that paper and I'm going to locate perfect squares. Now here's where 40 is. 40 is in between 49 and 36. And so I can see that 40 is not a perfect square. So I grab the calculator and I go 40 divided by 36. That doesn't work. And I keep working. 40 divided by 25. 40 divided by 16. And I realize the very first number that will work is 4. So 40 can be broken up into 4 times 10. 40 is broken up into 4 times 10. 4 is the perfect square. It allows us to break it apart. So I come back here and I'm going to rewrite this again. X equals -4 plus or minus. Now 40 is the same as 4 times 10. What is the square root of 4? Let's bring it back. What is the square root of 4? It is 2. So now I have x equals -4 plus or minus. This is equivalent to 2. Now, if you're the number on the bottom, you have to be excellent at sharing. So you have to share to the left or right. There's two sides here if you're confused. This is the left side. It is one quantity. This is the right side. It is one quantity. There's not 3 different separate quantities. We have a left and a right separated by the plus or minus. I'm going to come up into this open space here and I'm going to separate them. So I have x equals -4 over -2. -4 divided by -2 plus or minus. That allows us to get those two answers. And then I have 2 over -2. And I've attached the square root of 10. If you need to use a graphing calculator, then do so. -4 divided by -2 is an answer of +2. Great. So x equals +2 plus or minus. 2 divided by -2, if you need to rely, 2 divided by -2 is -1. This would be the exact answers. Now, if you're like me and you're like, oh, I wasn't really sure if I did that all right, let's check. This allows for 2 answers. It's a lazy way of doing that. Can everybody grab a calculator, please? And we're going to do adding the first time. Do 2 plus -1, then find the square root of 10 and get an answer. Then do the exact same thing, but I want you to subtract. 2 subtract -1 square root of 10. When you and your partner both have this, please put a green cup up. I want both of those answers. You have 20 seconds right now. Both of these answers. Help your partner out if they need help. What does that even mean, Miss Bradley? Like, where am I going with this? If these are the correct answers, I should be able to go back to the graph of number 3, and this should equal the approximation that I would have made. So let's find out right now. I'm going to grab right now, find number 3 here. I'm going to adjust my camera so those at home can see, along with those in class. And let's look. So it's 5.1. 5.1 is one of my answers. Would you agree if here's 5? Is 5.1 really close? Yeah, that looks about right. Is -1.1. Now, again, I am just estimating, but yes, -1.1 is right. So at this level of math, we do not want you to just estimate or to round. We want exact answers unless it asks you for something else. So please find where it says x-intercepts. I'm going to go right here. I'm going to draw a little arrow down, and I'm going to write down the exact answers. Let's write down this exact answers. It is, if I look back up here, it is 2. X equals 2 plus or minus -1 square roots of 10. These are the 2 exact answers. I don't want you to tell me negative 1.1 and 5.1. That would be estimation. I want exact. That's the hardest part of today's lesson, in my opinion. When do you have to do all this hoopla in order to get these answers? When you're not given precise x-intercepts to start with. Okay, we're going to go back to example number 1 right now. Please find example number 1. No, move it up here. Okay, here is my example number 1. And we're going to start off with the 3 easiest parts here. We're going to start by, please put, by the way, a box around the word equation. We don't just want a value, we want an equation. So to start this, we are going to start with the vertex. It's just very easy. It's given to us, negative 5, 4. The one mistake I often see students make is they forget to use parentheses. That's done now. We're good. Now, we want to write an equation of the axis of symmetry. The axis of symmetry is a way for you to look at this picture of this graph and you cut it in half so the left side would be the same as the right side. Every single time when you do that, you're going to cut directly through the vertex of the vertical line. And when you cut through the vertex with the vertical line, it crosses the x-axis, in this case, at a value of negative 5. Notice that the x-coordinate for the vertex will be the same as the value for the axis of symmetry. Now the key here is it says equation, so put an equal sign in front. And in front of that equal sign, we have to put a variable, an x or a y. It is always going to be, for quadratic functions, it will always be an x. I don't want you to memorize that. I want you to understand it. This vertical line crosses the x-axis at a value of negative 5. Will it always do that? Yes, for quadratic functions, it will always be x equals a value. Okay, what is the y-intercept? Okay, can you guys see the y-intercept? Do you see where this function crosses the y-axis? Yes or no? We don't see it. We'd have to guess. So you're going to flip your paper to the back. I'm going to take a piece of scratch paper here and come up front. And so when we identified so sorry guys, let me move this here. I'm so sorry. When we identified what the x-intercept was in example number 3, we made y equal to 0. It's the opposite variable becomes 0. So when I want to identify the y-intercept, and again, why am I doing this? Because I can't see on the graph where it crosses. When I want to identify the y-intercept, the opposite variable, in this case x, becomes 0. So I'm going to write down this equation, and wherever I see an x, I get to replace it with 0. 0 plus 5 is 5. 5 squared is 25. And now I end up with negative 25 plus 4. If you need to use a graphing calculator, you can do that. Also, you can think that negative 25 and positive 4, they're different signs. When you have different signs and you're combining, you're going to subtract. The sign of the larger number is negative. This tells me my y-intercept. Now, we always want to make sure, like, does that seem about right? So let's look back to the graph, and let's just do a quick estimation. Does that seem about right? So if this continued to go in this direction, eventually it's going to cross the y-axis. Do you agree that it's going to probably be somewhere down here, probably about negative 25 if I extended the y-axis? That seems about right. So we're going to come up here and write y equals negative 21. The only reason you need to do the algebraic method to identifying the x and y intercepts is if you can't see them on a graph or the graph doesn't provide us with precise values. So let's check here. We have a precise value of negative 3. So one x-intercept is negative 3. Then we have another precise value of, here's negative 1, 2, negative 3, negative 4, negative 5, negative 6, negative 7. I can see it precisely goes through the points. I don't need to worry about doing all that math. I can see it on a graph. Domain and range. So here is your x, here's your x-axis, and there's no limit how far this goes to the left as it goes down. There's no limit how far it goes to the right as it goes down. So there's no limit that this function will continue to move to the left and to the right. For that reason, we are marking this parabola as negative infinity to positive. Unless we're working with word problems, our domain for parabolas will not be limited right now. It's going to be from negative infinity to positive. There's no limitations to it. When we get to word problems, there may be some different constraints. Now, just like I looked at this problem in terms of the domain and I went from left to right, negatives to positives, I'm going to do the same thing with range. I'm going to go from negatives to positives. When I look at these arrows tell me there's no limit how low it goes. There's no limit how low it goes. There is a limit on how high this goes for a y value. Can anybody share with me, what is the y value that this extends to? It goes up as how far? Up. 4. And there's actually a point there. I need to include it. Okay, this next part, when we describe increasing, decreasing, although there's not one here, constant intervals, I need to remind us of these 3 things. We did this over a month ago. Increasing, decreasing, and constant intervals always have 3 things in common. One is they only ever use parentheses, just as a quick reminder. When you describe increasing, decreasing, and constant intervals, we only ever use parentheses and interval notation. Number 2, we have to read it from left to right. And number 3, we describe it only in terms of the x values. Those are the 3 things we need to remember about increasing, decreasing, and constant. In this case, we're only going to describe increasing, decreasing. Okay. So from left to right, would you say you're going up or down here from left to right? Up. And up is like increasing. So I'm going to come off the side and write increasing. Now, when you get to the top of this mountain, are you increasing or decreasing? Neither. You're taking a rest. You're taking a rest. You've stopped. But after you leave the top of the mountain, you're going to start to go down or decrease. So I want to describe this portion right here that I'm going to do in purple. I want to describe this portion right here. And so right here where I find increasing, I'm going to start by putting parentheses. That's the first thing. Put parentheses. In fact, we're going to use parentheses for decreasing too. Now we have to read this from left to right, and we did that from left to right. That's how we determine what part was increasing or decreasing. So I've done left to right, and I've done parentheses. Now in terms of x values, this is the complicated part. In terms of x values, this entire portion of the graph is always going to be increasing. I could go all the way over to negative 10 or negative 20. This entire portion of the graph is always increasing. I can go as far as I want to the left, and it will always increase until it gets to an x value of negative 5. At negative 5, it stops, and it takes a rest at the top of the mountain, or the top of our parabola. Then after it leaves negative 5, what's going to happen? It's going to start going the opposite direction and start going down. So in terms of x values, as I move to the right, after negative 5, as I move to the right, it is going to go down. As I move to the right, it is going to go down. A big misconception is students want to put a negative sign in front of this symbol of infinity because they said, look, miss, it's going down. Don't you need to put a negative in terms of x values? As it moves to the right, it decreases. Okay, so this particular point is a high point. We're going to circle maximum. I'm going to come back to the average rate of change in just a second. Let's go down to end behavior. About a month ago, I reminded you, I said, hey, wouldn't it be great if we all had stamps here? Please write this down, and then we'll go through and we'll describe it together. Okay, what does this mean? So I'm going to grab, and I'm going to circle in pink. So I'm going to make a big oval off to the right and a big oval off to the left. You can do the same on your paper. If this parabola eventually crosses into this oval, one of 3 things happens when it crosses into this oval eventually. It's going down, it's going to be headed up, or it's going to be flat. It's going to be horizontal. So when this part of the function crosses into this oval, which direction is it going? Down. How do we describe down? When we go to the far left, it's headed down, negative infinity. When this part of the function crosses into my pink oval, eventually it is also headed down. The nice thing about parabolas is, look, they're both going the same direction. They're both going down or they're both going up. So your end behavior for parabolas will both be negative infinity or positive. They will be the same. When you see average rate of change, you should think the word slope. Come over here and write slope, please. I want you to identify where can you, this is not an ordered pair. Where's negative 5 for an x value on the graph? Where is negative 3 for an x value on the graph? So I'm finding negative 5, it's right here. I'm finding negative 3, it's right here, and I want to connect them. Please do the same using your pencil or pen, whatever you have. I want to describe in terms of math language what's happening from left to right. So if you had to describe to somebody in simple terms, like let's just make this very basic. What's happening as you go from left to right? What's happening? It's going down. So we know it's going down. Put a negative sign here. And now we're going to say in terms of math, we're going to say how fast is it going down. I'm going to show you two different ways to do this. You have to know how to do it both ways. One is we're going to count. We start here, and please write down the words rise over run. You always go up and down first, left or right second. So we're going to count, and I'm going to go straight down until I'm horizontal here. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. I just went 8 down. So 8 down. That's not an infinity. That's a negative 8. 8 down. Okay. Now I have to go to the right. 1, 2, 3, 4. Negative 8 divided by 4 is negative 2. I believe the rate of change from negative 5 to negative 3 is negative 2 over 1. You may have understood my math, but you're like, I really don't know what that means, miss. It means on average, if you start here and we go from left to right, if you go down 2, right 1, 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 you'll end up at that last point. That's on average what happens. Now, algebraically, is there a way to do this? There is. So come back grab this. You've learned this in 8th and 9th grade. It doesn't mean you've mastered it. So now's the time to review how to do this. What does negative 5 go with? Look over here. What is the output when the input's negative 5? 4. Find negative 3. What's the output when the input is negative 3? Okay, please write x1, y1, and x2, y2. And this goes back to the slope formula that you learned in 8th and 9th grade. Okay, I want you to plug in the numbers that correspond with y2, y1, x2, x1. Whether you use a calculator right now after you plug those in or you use mental math, I want you to get an answer. Zero minus 4 is negative 4. Two negatives make a positive. Negative 3 plus 5 is 2. Negative 4 divided by 2 is negative 2. And that's the same answer as when I went up to the graph and I simply counted. I like to do the least amount of work. So if somebody said to me, like, why would I take time to do this when I can just count? The reason is you're not always going to be given a graph. And sometimes the numbers on the graph will be decimals and you can't count like I just did. So sometimes this is your option, sometimes it's not. And for that reason, we have to be able to use this formula. All right, we're going to go on right now to number 2. Please learn your partner's name if you have not done so. Go ahead, please learn your partner's name. I have 5 check marks. I'm going to give you 2 minutes working with your partner to. So let's start with this vertex. The vertex is given at 1, negative 2. Make sure you have parentheses around those. Next, I'm going to make this vertical dotted line, and it's going to cut that parabola in half. Whatever the x value is will be the value here for the equation, x equals 1. Why? Because it cuts through the x-axis at 1. The y value is y equals negative 1.5. The x's are exact at positive 3 and at negative 1. Positive 3 and at negative 1. Now, is this a maximum or minimum? Minimum. Okay, so let's talk about domain. What did I tell you all parabolas will have right now? All parabolas, there's no restrictions. That means negative infinity to positive. It will continue to move upward as it goes to the left and upward as it goes to the right. We always start by going negative to positive. So when I look at the range here, how low does this go? Does it go as low as 1 or as low as negative 2? What is the y value? Negative 2. And there's no limit how high it goes. For this particular problem, we always look at this from left to right. Remember, increasing or decreasing. First thing, just put parentheses. There's three things. Always use parentheses, always read it from left to right, and then use X values to describe it. So I'm going to start from left to right. What would we be doing? Going up or down here from left to right? Down, decreasing. Then here you get to rest when you're at 1, and then here we're going uphill or increasing. So I want to describe this portion right here, this portion of the graph. It comes from the far left. How do we describe the far left for this decreasing interval? How do we describe the far left? Negative infinity. And it goes all the way to what X value? At this X value, it just gets to stop and rest. What X value allows it to stop and rest? 1. Now, after it leaves 1, it's going to start to go uphill or increase. So as it moves to the right, it will continue to increase. I'm going to come back to average rate of change. Let's do end behavior. Please write this down. As I go to the far left, as I go to the far left, and as I go to the far right, both ends are moving in what direction? Going up or going down? Up. How do I describe this? I don't want you to write the word up. We're going to write positive infinity. Let's go back down to average rate of change. I'm a visual learner, so I'm going to identify where is an X value of 1 and where is an X value of 3. As a reminder, this is not an ordered pair. So find 1, okay, here's 1, find 3, and highlight it, darken in, whatever you need to do. If you're going to read this from left to right, so you start at the bottom and you go from X is 1 to X is 3, are you going uphill or downhill? Uphill. So we know up, the slope will be positive. Let's put a positive down. Now, how fast are you going uphill? I think I could actually use the graph here and make this easy. Let's try. Rise over or run. 1, 2, 3, 4. I went up 4. And now 1, 2, 3, 4. I went to the right 4. 4 over 4 is equivalent to 1. But what if you're given the equation and you don't have the graph? What do? We're going to go over that right now. You're given this equation, so please do me a favor and write down the equation. Flip to the back side right now. We're going to practice this together. You're asked to find the average rate of change between X is 1 and X is 3, but you don't have a graph like I just worked with. Grab your calculator first. We have input values, but we don't know what they connect with. So how do we figure out what the output is? Grab a calculator, please. You're going to do this with me. We're typing in 1/2 right now in parentheses. Anytime we have a fraction, we put in parentheses. And then I have 1 subtract 1 squared subtract 2. When I substituted in a value of 1, the output is negative 2. Please do the same now and substitute in a value of 3. When I substitute in a 3 instead of a 1, I come up with an output of 0. Why did I choose 1 and 3? Because that's what the problem said. This problem said, tell me what's happening between 1 and 3. Tell me what's happening. Now, I'm going to use these two ordered pairs, x1, y1, x2, y2. I'm going to use these two ordered pairs in order to come up with the slope. The slope describes what's happening. So let's write down y2 minus y1 over x2 minus x1. Okay, you ready with your partner? Please plug in the numbers. Then using a calculator or mental math, come up with the answer. I'm going to give you 15 seconds and go. Two negatives results in a positive. 0 plus 2 is 2. 3 minus 1 is 2, and 2 divided by 2 is 1. That's exactly what we got, 1. What I'd like you to do is the following. We have already started this class by figuring out what is the exact x-intercepts. I would like you to do the remainder of this right now with your partner. Begin.